back out in the layout room with the new point, and just checking it for size and shape and I suppose fit. It seems to be a perfect match to the original point that I was going to use in this position, the 125 point, the Coke 125 point. However, there's one or two little jobs I need to do and one big job before I can install it. I need to finish off the point, obviously. There's the tie bars need to be done, but this hole here needs to be pre-drilled for me to allow me to get the switch machine and its actuating rod through the hole up into the tie bars. I want to do that before I install the point, because if I do it afterwards, there'll be the tie bars and all the rest of the point will be in the way, and there's a good chance I could damage it. So I'm going to draw a little hole here and drill a hole into that section. And the other big job I need to do before I can go much further is I need to install all this bench works. It's actually all just sitting on the layout at the moment. This is all new benchwork, obviously. You can see from the colour of the wood that it's fairly new. And this is the pre-existing benchwork of Queen's Wharf. So I'm tying these two sections of layout together, the original layout. Because of that, this is not actually this is cut. Take the point out of the way. This is actually cut up, but it's not installed yet. From the look of the point sitting there, and the rail sitting up against each other, it's about 2 millimetres too low. I need to put a riser in there and bring that up. But I'm going to do that carefully and slowly because I want that to be a good match. I can actually drill this hole now, however, because the point is actually pretty much ready to be installed, and I want the benchwork to be in the correct location, but I'm pretty confident that it's in that location, and I can drill this hole. Once the hole's drilled, I'll put the tie bars in place. I'll install the risers along here. There's a fair number of them. If I can do this without bumping the camera too badly, you can see that this piece of benchwork is quite long. It's about 5 foot long, and it's in two sections. I also want to extend. the sidings down this end of the yard a little bit for various purposes. Possibly there's two sidings there. One on the left may probably go maybe another 30 centimetres further on, and the long one on the outside towards the front of the layout, I'm going to extend that down to the end of that piece of benchwork you can see. So it's another, say, probably 40 centimetres, maybe a little less than that. The hole I drilled between these two sleepers in the track base was 8 millimetres. It's on the centre line. I don't know whether you can actually see that, but there's a centre line drawn on the template, on the paper template, and I just drilled down. It was the largest drill bit I could get between the two sleepers without doing too much damage to them. One of them did actually take a little shave off. I'll probably give that a bit of a touch up with a coloured pencil or marker pen at some point. Now, it might seem obvious to anybody who's reasonably experienced with woodwork that you drill a hole through the benchwork now. But as I said before, one of the things I wanted to do when I started doing this video series is to, I suppose, to talk about and demonstrate some of the techniques I use that seem fairly obvious, but I still think don't hurt to be explained. I remember watching a cooking program many years ago, and the lady, I think it was an English woman, was doing what she called a basics cooking program, and the first thing she did on the program was cook an egg, and she boiled it, and she talked about the water, the temperature, and getting it out of the tap and things like that. I don't know where the intelligence or the capabilities of the audience was sitting, but she obviously felt she needed to demonstrate right back to the basics, not make an assumption that anybody would know what boiling water was like. So she actually demonstrated boiling water. So excuse me if I seem a little bit obvious when I say this, but I'm going to drill a hole here. So what I did, to go right back to basics, what I did was I laid the point on the bench work, line the track up, line the rail up I should say, and then I've redrawn around that track base. The track base is a little different to the one that, just a touch different to the one I started the series with, because I've redrawn it, cut it back, sanded it, filed it, rasped it, made a whole series of little changes to it, so it's not quite the same. Then I redrew around the track base. It's a little bit different, but as the original point was, as the base for that one was drawn from that original point, it can't be too different. This tool here is a little woodworking tool. When I was a young whippersnapper, they used to call these things braddles, but whatever it's called, it's a handle with a pointy tip on the end. You know, stabbing someone with it, I suppose, if you really wanted to. To get that hole where I want it to, I'm going to do two things that may not seem terribly obvious. May seem terribly obvious to me, but may not seem terribly obvious to somebody watching this who doesn't do much woodworking. First of all, I'm going to mark the centre of the hole. So I've drawn a hole, and I went round the outside edge. When I was drawing it, I made sure that I got to the edge and moved the pencil in an arc round like that, so that it actually touched the edges of the hole, that 8mm hole. By eye, I can mark the centre of that hole. But rather than just drill it straight out, what I'm going to do is I'm going to mark the centre of that with this braddle, or this tool, so that I know I've got a relatively centred hole. The other thing I'm going to do is I'm going to drill the hole with a 12mm bit with a point. So this is an auger, something like an auger bit. It's not a true auger bit, it's a woodworking bit. So it has a point that will help you centre the hole. Now, why am I making taking the time to explain how to drill a hole? Well, the reason is because I want that hole exactly centred under that 8mm hole. I'm using a 12mm bit, which is, you know, obviously a little bigger than the 8mm bit, because I want to give myself a little bit of wiggle room. If I drill exactly 8mm, all I'm going to be left with is an 8mm hole, and I'll have to get it right under that hole. The tortoise doesn't need 8mm, it needs about 5mm to have its complete swing straight under the point like that. But remember, this is an O-scale point, it's not a HO point. The travel of the point, of the switch rails, is quite a bit bigger than a HO point, so you need plenty of space. Making it a 12mm hole makes no difference to the tortoise. It won't affect where I screw the tortoise to the base of the track, but giving me that extra couple of mil either side will give me a little bit more space. So, centering the hole with the bradawl, centering the drill bit with that point, and then drilling. Becomes a relatively simple matter. We get a few chips underneath. Now, my point is this. You couldn't see that probably on the video, but I could see as the drill bit came into contact with the surface of the wood, it was perfectly centred in that hole. So it's right where I need it. I can't do that once the point's installed. What I can do is I can do it now. That's why you need to be thinking ahead and just planning a little bit before you install things like this. This goes for this thinking is true for installing any sort of track work, hand-built track or set track or anything in between. But a little bit of thinking ahead of time. Now, I don't always get it right. Don't get me wrong. I make mistakes all the time, and I have to go back and fiddle with things and get them in place. But because I'm thinking ahead, because of this video, I wanted to make sure that this hole was where it was meant to be when I came to install the point later. Okay, we're back at the workbench, and I thought we'd start by before we do this last phase of point construction before installation. I thought I'd just go through a couple of bits of, spend a little bit of time looking at materials. The materials used in this are fairly straightforward and readily available at most hobby shops and online, but they tie together, and both literally on the model, I suppose, and together as a set of steps. So they interact with each other in a way that is required that they fit inside. Some of them fit inside. So you need to get something roughly equivalent to this to make this work. Now these sleepers are about 3.5mm thick from the base up to their top. That's a reasonably important dimension now. not a terribly important dimension up till now, but it's important because the tie bar needs to fit underneath that and have plenty of room to move. So let's start with the tie bar itself. Now I use a piece of PCB sleeper. Ironically, considering I don't have anything to do with PCBs actually in the construction of the point, I do use a piece of this as the two tie bars in those two sections that I painted earlier in one of the earlier parts of this video series. These are HO ones. They're left over from my days as a HO modeller, and as I haven't modelled in HO since the beginning of the year 2000, so getting on for 18 years now, 17, 18 years, and I've still got probably 10 or 11 pieces of this left over, you can see that one bag goes a long way in this application. The thickness of this stuff is 1.43 millimetres, and the width of it, which is the critical dimension, is 2.45. Now these tie bars go in there, like that. They're tweezers. You can ignore the piece of light coloured sleeper material, that's just a spacer I put in there for the moment. So it will sit. Actually these are double-sided, not that really matters, but it does help if you've got double-sided. So this is a tie bar, it sits about there, and you use all of about 45 mil of it in twice, so you use about 90 mil. There's more than enough for probably 4 points here, or 3 points. 2.54 millimetres is perfect because that gives, as the sleepers are 3.5 wide, that gives you about a millimetre clearance underneath. You don't want it scraping on the base of or the top of the template. You want it to clear that. So the HO versions of this sleeper material are perfect. How thick it is doesn't really matter a great deal, but how wide it is quite important because you put it on its side. Now I get this stuff. I bought this stuff. I've lost the label, so I can't tell you what type it is, but I know it's from Clover House, which is a US company that used to produce this stuff. I'm assuming they still do. I'm sure I've seen their stuff online for sale. So if you look for HO double-sided sleeper material, and it's sold as sleeper material, and they make a set of matching HO sleepers to go with it, or what the Americans call ties, obviously, that matches the dimensions of this PCB material, and some of that comes in the packet, or did in the packet I've got. Then you shouldn't have too much trouble tracking this down. So a packet, under $10, I would guess, and enough to make sleepers till the cows come home in this application. Okay. Now there are a couple of bits of wire sitting here. Well, I'll move to so I don't forget to talk about it, I'll move to the balsa wood that's sitting over here. This is in two thicknesses, 2.5, I just want to make sure I've got it right. I think it's 2 millimetres thick. Yeah, 2 millimetres and 2.5 millimetres. It's the thickest stuff at the bottom. I actually have this stuff on hand. We won't need this in the first step, but we'll need it in the second step. So I would suggest strongly that you get yourself some 2.5 millimetre material and get yourself a piece of 2 mil as well at the same time. It doesn't matter how wide it is, but it's going to be used as a packer behind the wing rails. Or, sorry, I shouldn't say the wing rails. The switch rails. So you will need to 2.5 is about perfect for this. It's a little bit wider than prototype, but it gives you plenty of clearance behind the back-to-back. So I've got a couple of bits of wire here. Now this steel, there's a piece of steel wire here, a piece of nickel silver wire, and a piece of brass wire. Now I've got the two pieces of nickel silver, the softer nickel silver and brass wire together because it's used as for the pins that I'm going to form in a moment that sit in here. Now, you probably don't get a very good view of that at the moment, but I'm going to try and focus the camera a little bit closer before I go any further and give you a better view as I do this next step. The 1.7 millimetre nickel silver wire, it's 0.7 I should say, yeah, exactly 0.7, and the 0.8 brass wire, yeah, brass wire, would be fine for this application. Either will do. I've used brass in the past. I'm going to use brass this time because it's slightly thicker and more robust. But I think for this, if you've got some nickel silver wire, it solders very nicely. It probably solders a little bit better than the brass, although the brass is fine. I would recommend either of those. What I've done, because I'm going to solder it, I want to clean it. I just get a glass fibre pencil and just run it lightly across the thing. You can do this with wet and dry as well, but it just cleans the end of the wire so that it takes the solder a lot quicker. You'd never try to solder, well, I never try to solder a wire that's been oxidised, because it just won't work. Now, this is a piece of K&S brass tube. Its outer diameter is 1.5 millimetres or 1.56, and its inner diameter is 0.8. And I know that because the piece of 0.8, well, it did go in there. I find with O-scale points that the material that's provided with the tortoises is not quite enough to do the job. So therefore, I tend to bulk it up a bit. It comes at about 0.5, I think it is. 0.8 is perfect. Now, just as a matter of interest, these are taper brooches. That one looks about right. They're just basically a squared off steel pin. All right. Now, what are you using for? Well, if you want to clean out a hole, there's nothing better. Just twist it in there like that. And if that's big, if that inside diameter is big enough to take the this steel tube, this steel wire, this will clear it out to enough at a distance. It's quite possible that the end of the steel tube, the end of the steel wire is also a little bit burred. So just do a little bit of deburring with a file, and I should have done this before I came on air so I didn't look like such a goose, that it will slip nicely into that tube, and it does, as you see there. Alright, so the piece of steel piano wire, which will be about maybe 10 millimetres, I'll make it about 10 centimetres long. I'll cut two of these and bend them up to the same shape as the diagram that comes with the instructions. Attach them to the two tortoise machines I'll be installing. I've got two. I need one to reinstall and another one that goes on this point. And I will be soldering a piece of this brass tube, a little slice of it, to the side of the PCB sleeper. Now, obviously, as these sleepers are electrically conductive, you need to gap them before you do it, and I do that with two gaps. I do one. I solder the piece of brass tube to the side of the PCB sleeper, and then I gap it with a file, with the edge of a file, either side of that piece of brass tube. I don't want to go anywhere near where I want to solder it to the workings around the point blades, but you must gap them, and you need to do that before you install it, because it's almost impossible to do afterwards. Okay, so those are the materials. But for this step, well, that's actually more materials than I intended to demonstrate. I'll put these brooches away. The next step is to form the pins that will go will be soldered onto the switch rails, and then be used to attach the sleeper to, which is the tie bar. Now, you probably can't see that, but there is a tiny little piece of brass here. I'll hold it up to you. With any luck, you may be able to see that. Out of the light, probably no good. That's a little formed piece of brass. I've decided to do this in front of the camera, no matter how long it takes. And this is one of those jobs that requires three hands, so it might be a bit fussy, or it might work the very first time I do it. So if I look clever, it'll only be because by pure chance, I can tell you. So I'm going to put the nickel silver wire aside. All right, I have some solder. It's just straight rosin cord solder. All right, I've got some non-corrosive. What I'm sure is non-corrosive solder flux here, acid flux, which I'm running a bit short of actually, and I've got a bit of brass wire. I don't need any of these things, but I'm going to actually do this in front of you now. I've got a pair of pliers somewhere here, a small pair of pliers. Now these pliers, across their face, about 4 millimetres in, are about 3.7 millimetres. I tend to use the ends of pliers as a gauge, and these have a stepped little piece at the end. I need to make two bends in this. I take the clean end, and when I say clean, it's been cleaned with a brass fibre pen, but it's also been cleaned as in I've brushed it with a file a couple of times. I will put it in the pliers and bend it. But what I'm going to do first is I'm going to tighten the angle on the camera. Okay, so those pliers are about 3 millimeters across that way, and I use the width of the pliers across as a bit of a gauge. I go down and I make a simple 90-degree bend with the brass, simple as that. Okay. Now these pins are handed. This one is bent one way. I now need to bend this pin the other way. Alright? So it needs to go that way. I need to grab it like that. And I need it to go, no, that's the wrong way. So I put it away from me, grab it like that. And I want the pliers to go into about 2 millimeters. Shorter than this distance, that's about 3-4 millimeters. I want about 2 millimeters that way. And I want it to be at 90 degrees to that other bend. And it's going to bend down, I'm going to bend it down. Like that. Okay? And I want it at 90 degrees. Alright. So. If I'm lucky, it shouldn't be the same, it should be the opposite of that pin there. So I take a pair of nippers, my trusty Xeron cutters, and I cut it about another 2 millimeters down. I'm not quite happy with the bend in that, just hang on a sec, not quite 90 degrees, and it's not sharp. I like the bend to be a little bit sharp, just nice and crisp. Okay. I need to, now, so one thing I didn't mention before I started is I actually use a full length piece of brass before I start, so I don't try and bend a little short piece. So don't ask me how long the brass piece would be, I really don't know. I make it 3 millimeters, 2 millimeters, 2 millimeters, so that makes about 7 millimeters, 5, yeah, 3, 2 and 5, 3, 2 and 2, so about 7 millimeters long in length, but I will cut it along its bottom edge. So now I have 2 pieces of brass. Now I'm going to make 2 more of these because I need 4 pins. And my recommendation is, as you'll probably pin one in the middle of off to the middle of nowhere, it's sometimes a good idea, as you're making them already, to make 4. To make 5. So you've got a spare one of each side. So you'll actually make 6. Make 2 spares. That way you've got one of each side, and you're bound to lose at least one. That's what I have, and it's because I'll be using pliers. I'll be using tweezers to hold it. And almost always it'll go flying off to the middle of nowhere. In spite of my own advice to make 4 of these, I didn't make to make more than 4 of these. I didn't make any more, but I've got the 3 left that I haven't used yet. You may be able to see in here that I've actually soldered one in place. I wanted to test my technique and not waste your time, but I'm determined to do this in front of the camera because if I don't feel like I'm giving you a clear indication of how fiddly this can be. Now. This material here, this wood here, is a sleeper, a piece of sleeper material, so it's the same thickness or depth as these other sleepers, but I've just trimmed it down the centre. It's about, exactly, that was a guess, that was a good guess. It's exactly 3 millimeters thick. Now, the reason it's 3 millimeters thick is because the distance between these two, I want this to match the distance between these two and bring the pin, as I solder them in place, about halfway down the middle. I can choose which side I want it to be. I can choose which side the tie bars will be, but I tend to do it on the opposite side and then put the brass tube on the inner side. So what I'll do is I will solder all 4 pins in place. Put the tie bar there like that, and then I'll very quickly solder that join there, and on this side obviously this join here. You won't be able to see it. When I'm soldering these in place, these little pins that I've formed by the bending of the brass wire, I want them to be equally as distant from the sleeper. You can put them at an angle if you like, different depths. But if you do, your tie bar will be uneven, or it'll look at a skewed angle, and it'll stick out like a sore thumb, or to use a more fragrant Australian phrase, like dog balls. It'll stick out like a sore thumb and be very obvious. Aesthetically, it looks awful, but it has no functional difference. But I would suggest strongly using the packer so that you can space them. So as you may be able to see, there's this piece of brass wire is about probably 4 millimetres long that way, about 2 and a bit millimetres that way, and about 2 millimetres and a bit down. Okay, so I've got one soldered in place already. I put the other one there like this, so it's just sitting on the thing. Now, as I said before, you need about 3 hands for this. I've clipped the switch rail to the stock rail just quickly. You obviously don't want to solder those two together, so it's quick and fast, and don't let the solder wander too far. I'm going to put this, I've got to hold it from this angle, because if I don't, I won't be able to hold it, and if that blocks your view, I'm sorry, but I'm more interested in showing you how long it takes. The important thing is you get the little bit of the pin that's going down sitting hard up against that piece of sleeper there, but you want the pin to be straight down. And funny enough, it's about perfect where it is. No, I've moved it again. Getting the position right is the hardest bit of the whole job. And the next hardest bit is getting your hand over to the soldering iron fast enough before it shifts, it all shifts. So, tiny little dab of flux, and you will have your solder ready to go over there. Touch the solder, I don't know if you can see that. Oh, it's shifted, hang on. It's no good soldering in place in the wrong position. Okay, that's about right. Oh, isn't that amazing? A little bit more solder flux. And there we go. Solder on the tip of the soldering iron. No, it's moved again. Getting it into position is one thing, holding it in position is another altogether. Let me see if I'm ready to go. It's very difficult to change it. Ah, perfect. Now, ironically, so my demonstrated incompetence is clear for everybody. Ironically, the first one I did, that one I did off camera, went beautifully, which is why I felt confident to do, and I didn't solder these switch rails and thing, which is why I felt confident to turn the camera on. So now I have 2 pins. You can see they're just soldered in along the inside, in the web of the switch rail, with a bit of a bend out to clear that, and just a piece that drops down. So I will have, when I solder the other side, I'll turn the sleeper I will turn the switch right around and solder from this side on the other side, and then I will have somewhere to solder the tie bar too. Okay, we've moved into the construction of tie bars. Now, these are the 2 tie bars here. I've cut them from the length of PCB, which is there. As you can see, it's they're fairly short. I made them just on 40 millimetres long. I started by making one of them, soldering the tube to the centre here. You probably can't see that very clearly, but there's a little piece of brass tube just soldered to the centre, and I marked the centre because I want it exactly in the middle, and I've gapped each side of that with, you can see that, with a 3-sided file. Just the thing, I'll check the continuity to make sure there isn't any of the copper clad left there. The only really, I suppose, questioning I have in my own mind about the way I do this is, how do I cut the tube? Well, the only thing that doesn't seem obvious to me with this is, how do I cut the tube? Well, you might think, oh, you get a saw out, but I actually use a knife, a blade and a Stanley knife. And this does basically ruin the Stanley knife, but an old one will do, an old blade. So what I do is, I want it about, it's about 2 millimetres. What is that? I haven't checked. It's about 2 millimetres thick, maybe 2.5 millimetres thick. Yeah, just over 2.5 millimetres thick. Wide, I should say. I want the tube to run the full length of the tie bar to give it a bit more surface area, and I've cleaned one end of that tube on the outside. All I do is place the standing off about, roughly 2.5 mil from the end. Just roll it backwards and forwards. I'm not pushing hard enough because I'm trying to give you a view, and pretty quickly it'll work its way through the tube. So I've got a little piece of brass tube there now. I'll clean that up. Before I solder it to the thing, to the tie bar. It's a little bit longer than the other one, but I can either file it down or not worry about it, and just sit it there like that. And then I may actually file that a little bit off camera before I put it on, but essentially that's the way they're made. Okay, we're up to pretty much the last step in constructing our point, and I've got everything set up to solder the tie bar, the second tie bar in place. You may be able to see that I've got the first one already soldered in there. It's sitting up just against the pins, and I just touched it with the soldering iron. Just to explain what I've got on show here is the piece of 2.5 millimeter balsa wood, just a sliver of that. I'll just cut that about 1 centimetre long and just split it in half, and it's packing out the back of the switch rail. That's held together with a couple of these little hair clips that I've shortened off. The original versions look like that. A couple of them I've just shortened. I've kept a few of them the full length. And I've got that packed in there. I've got the other side packed against the curved stock rail, but it doesn't matter which one you use, either the curved or the straight, to pack it out. They're now where they're going to sit when the tie bars are soldered together. I use 2 tie bars because there are 2 on the prototype that I've modelled, and because that adds strength. There's no hinging or any sort of. This is soldered together in one solid lump, so there's no hinging. But because the points only move 2.5 millimetres, and they don't operate every day for dozens of hours, for a dozen hours, they only operate once a month when I run a train. Things sit as is until I use it, and I find that nothing's ever come adrift. There's obviously a little bit of stress on the soldered joints, but you grab a soldering iron and refix them and fix them again. So one great thing about building your own track work, models, whatever, you build it. If it breaks, you fix it. It's relatively straightforward. Now there's 2 bits of paper I've got in there. This is just typing paper I got out of the computer printer in my office, in my home office, and the reason I've got that in there on both sides, under the rail and between the tie bar and the underside of the rail, is because I want just the ever so slight sliver of space between the top of the tie bar and the rail, because it sits under the rail and brings the rail down to equal the height on the top of the rail. If I was to solder it, when I lift that tie bar into place and solder it, if I was to solder it without the paper in place, there would be no gap between the bottom of the rail, the underside of the rail, and the top of the tie bar. I find that the thickness of one piece of typing paper is enough to give me that micro sort of gap I need. So what I'm going to do is try and do this in front of you so that it doesn't look like I'm bodging this up and I'm doing something hard behind you. I go in there, lift the tie bar into place. I'll just make sure by lifting that paper that it's about the same distance. Yep, it's about the same place. And one of the mistakes I made in the previous seam was I was putting a piece of brass tube on this tie bar, because it turns out that there's no hole for actuating rod from a tortoise machine going through this one, so there's no need for a piece of brass rod. You only need the piece of brass rod on a single one. Okay, so I'm in there. I don't know if you can see past that clip. Just touch it like that. Touch it like that. Done. Finished. Basically the point is finished now. Just remove the clips and see if it actually works. Pull the paper out. Pull the paper out. Pull the thing out. Okay, so there's a little bit of flux has dribbled down there, but as it's not, as it will dry out, and basically it should be fine. All right. I I did actually scrub the brass. I took the this tie bar out to the sink and scrubbed it with some Jif, and that's a kitchen liquid, cream liquid gel. Sorry, it's a cream liquid house cleaner, and it's slightly alkaline. I scrubbed it around that rod. Now I can't remove all the flux from here unless I took it out and scrubbed it under the tap, and I'm not going to do that. But I wanted to remove as much of the flux as I could from the brass tube, because the piece of rod coming through from the switch machine is steel and will rust. So I thought if I remove that, when I'm able to get at it with a scrubbing brush, or it's actually a toothbrush, and some flux and a bit of water, that reduces the possibility of the rust starting the minute I put it in there. Now, as a bit of a rough test, you just push it side to side. Now you can see that that's, and I can assure you that I'm putting virtually no pressure on that. It's not loose, it's not sloppy in there, but there will be no problem at all in the tortoise, from my experience, shifting that across. All right. You just need to make sure there's enough of the tie bar under the rail to keep it that it's in all of its travel. It'll go across. I haven't got the bogey or the truck with me to run it through, but I will finish off by installing the point up on the layout and running that through, and even possibly running a loco backwards and forwards into it to let you see it operate. But essentially the point is finished, and I'm very happy with the results. I'm just doing some prep work for this, for putting the styrene blocks in between the rails here to make sure that the isolation gaps around the frog don't close up and we don't have short problems. I've cut up 4 small 1mm thick styrene blocks. They're about between 1.5 to 2 millimetres wide and about 5 or 6 millimetres long. That's well more than enough to satisfy what we need. I found the need for this even today. The point was sitting with the gaps unfilled with styrene, and in sitting out in the shed in the heat, these gaps yesterday would take a 1mm thick piece of styrene quite easily. Today they wouldn't. This afternoon they wouldn't. So what I've done is I've inserted one piece of styrene just there where my finger is. I'm going to put some super glue, which is just Zap-A-Gap, medium Zap-A-Gap. I'll put a block of styrene there. I'm just going to touch the top of that on both sides so that there's a little bit of a bond between it and the styrene. Normally I'd let this glue go off on its own at its own pace, but I've got a little bit of zip kick here and I'm trying to move things along, so I'm just going to touch in there with this cotton bud to harden the glue up a little bit and make things move a little bit faster. So I don't want to move anything. I don't want to go at the attack the styrene with knives and things until it's sort of set. So I would start by simply trimming off the styrene at the top like that, getting a fairly sharp blade. Perhaps any blade will do, but a scalpel blade, and then just working at the styrene to trim it down. So when you're happy with it, I want to trim the tops a little bit, trim on the running side, get it to a reasonable profile so that it doesn't look too out of place, and then when it's just about where you want it, you might just trim that bit a little bit more on that side. You come back and paint it with some rail brown. Okay, we're back out in the layout room, and we're working on installing the Code 100 point that's into its final location. The way I install the points, and the reason I use 0.4mm as a base, is that it allows me to securely tie these in position with something a bit more substantial and in that sense a little bit more robust than track pins or other small nails. What I use are these small gauge 4 screws. Now these are, the one I've got in my hand here is a gauge 4 brass 1/2 inch screw or a 12mm screw, and they're more than adequate for the job, but I've just picked up 200 of these little zinc coated ones. They're exactly the same type of screw, except they're about 8mm instead of 12mm. I drilled some holes on the centre line down the length of the turnout, one at the base here, or the heel here, 2 at the entryways and one in the centre. I could put a couple more in if I really felt I needed to, but at this stage 4 is plenty. The way I secure this method, I should say, of securing the point into position is the same way as I secure the track that you can see spread around it. So I do countersink the holes first with a larger drill bit, but the drill bit I use is just appropriate for the size. I just put it in position, drill a hole through, and then just screw it into place. Simple as that. Now, the point has been installed. I've run track up to it on both sides. The point motor is down here installed and labelled QW3, which, because it's the 3rd point in line, is the reason it's Q3. I've yet to trim the brass, sorry, I should say the steel wire that comes through to hold it up, and I've tested this and it works fine. You can actually push a tortoise with your fingers and it will gradually move over, and it seems to be working fine. Everything's working fine. In installing the point and installing the track leading up to it, I managed to do a little bit of minor damage to the wing rails here in the Frog, which I needed to remove one of the rails and reset it. Something was wrong with the gauge. I'm not sure what it was, but in putting it in, I'd managed to push it out of line. But because this is a hand-laid point, pulling the pins out, trimming the rail or inserting a new piece of rail and repinning it in a new, slightly altered location is the easiest thing in the world. It took me about 5 minutes to fix that. I've got to reinstall the styrene block in this section here. The aim now is to do the wiring, get the wires from the tortoise hooked up, rewire the layout in this section. There's no wiring near this part of the layout. I've pulled the wiring further down the line. I've pulled it out, the wiring out, and I'm going to test a train through. So we'll be doing that as a bit of just as a final step in this process. Turn the sound off that locator because it is fairly loud. This is the last, I suppose, scene or sequence in that in this video. This 3rd or possibly 4th. I might split it into 2. This is the last sequence in the video because it's essentially to demonstrate to you the point working or operating as it should be. It's been wired up. I thought I might just quickly finish by just explaining what the challenges of, just some of the challenges of this were. Not so much about the point, but in terms of incorporating into the layout. This particular switch is the 3rd in line that sits in this direction up there. The reason it's been a bit of a challenge is twofold. First of all, this layout, this part of the layout here, Queen's Wharf, is something like 15 years old, and it's probably been 12 years since I've actually done any work on it. Aside from knocking it about and bashing it about, it's sat in a corner in storage. Incorporating new track, a new section of layout into that old layout has been a bit of a challenge, because essentially the wiring from here back and beyond, where you can see on this part of the layout, is 15 years old. And because of that, what's under there and what I did 15 years ago is beyond my memory. So about 3 or 4 years ago, I brought into the equation this object here. This is an NCE product. It's called a Switch 8, and I'm using it to switch the points through the DCC system. It's sitting here because it's convenient. Eventually there will be a piece of timber across here, and there'll probably be a plug point for the DCC system, and it'll have scenery over it, a thin shell of scenery over it. But the reason it's here is because it's nice and convenient to get at while I'm programming. As I'll probably virtually never program it again, because it's currently programmed with all the points that it's going to be interacting with, I decided not to put it under the layout. I decided to put it on the front of the layout, where if I need to get at it later, it'll be underneath, but it'll be nice and close and towards the front. The light won't be any better at the front of the layout because it'll have scenery sort of sitting like here, but it'll essentially be a lot more accessible. And if I really need to get at it, I can undo those screws that are holding it in place and pull it out. So this point is wired up for this on this machine. And another thing that turned out to be the case, even though this was only 4 years old, was the first terminal I had it connected to didn't work. So the Switch 8 became a Switch 7, and it now has 7 points attached to it. This point, as you just saw, operates flawlessly. It's number 13. Its programming number is number 13, so all I did was punch number 13 in and have it switch or change direction. You probably won't be able to see this, but I'll do it in front of you anyway. You just select accessory, number 13 is already punched in, and if I'm not mistaken, it will switch and change. You might just be able to hear the tortoise. That change of direction was, as I say, the last step in this building process. I'm really happy with the switch. It has, I suppose one thing I didn't explain was it has dropper wires from the outside rail, from the wing rail, switch rail I should say, I suppose the right hand one if you're looking from this direction, a dropper wire from the other switch rail and the stock rail on the outside edge. It also has two wire droppers from here, from these two closure rails, and it also has a dropper wire from this cast frog. The cast frog is a little bit thicker or a little bit higher than the rail. I did shave it down a little bit by filing the back of it, but I probably could have done a little bit more of that. The one thing that perhaps I didn't show on camera was that to solder that solid piece of material, brass casting there, I used a big 80-watt soldering iron. I have a small soldering iron that I use for most of my soldering, but for this job, which is a 40-watter, but it has a variable temperature on it. Even turned on fully, I didn't expect it to do the job, so I used a big 80-watt iron to do that, and it did a really good job. One of the discoveries I made as I did a bit of archaeology under this part of the layout, or under the old part, was that neither of the previous points at this end of the layout had droppers from their switch rails, so the loco got to about within about 600 millimetres of this switch and just came to a dead stop. So for all of that 15 years, I'd been relying on the switch rails to conduct electricity along to there. And why I did that? Well, that was 15 years ago, so I don't know why not. It just didn't happen. So the layout has been rewired from beyond, down to the end, up to here. I'm now going to move on and wire the rest of the layout up, but essentially that is the end of that process. It's wired up, the point has been programmed, the switch motor is installed, and it's essentially finished. So I hope that any of you who managed to get this far in this video series got something out of it. I thank you very much, and by all means leave a comment or leave some feedback on the blog, or on YouTube and let me know what you thought. Thank you.